Okay, so here we have the 2020 pre or the mock exam for DCG. So this is question B2, so a long question, and it's based on laminar planes. I'm going to get straight into it, and hopefully this will be of help. So first off, we've been given our distance across from the left hand side of our page, and our distance up in elevation and our distance down in plan, if you don't already know that. So we come over, right, up, down, and these given us our coordinates for each of the following points. You can see here for D we're missing the height in elevation, but it's indicated that it's height h, which means we have to be able to find it somehow, and you can see that it's in actually part B of this question. So first things first, part A, draw the given plan and partial elevation of the two intersecting planes. That's because we won't be able to find point D straight away, so we'll only be able to plot A, B, C and E. We won't know where D is just yet. We'll know what line it's on, but we won't know where it is. So I'm going to get straight into it. So I'm going to set up my drawing board here. So roughly come down halfway the page, so come down 150 millimeters, and I usually just draw a horizontal line which acts as my XY line when I'm done plotting my coordinates. I'm going to come over my A, which is over 145, and just label it A, B. You can skip this if you know exactly what to do. Got my 5 points. Now I can just draw projection lines going both to plan elevation. Construction lines, you might be able to see these if I don't draw them there. So again, trying to keep this as light as possible so you don't clutter up the drawing. There we go, and now I can plot my height. So I'm going to start with E. So E is up 100 in elevation and down 45 in plan. A is 55 and 5. C is 50 and 90. And D, we don't have the height and elevation, but we know it's 40 down. D. So now we can draw, or we can join these up. I like to use two different colors so that I can distinguish the two planar surfaces. So for this instance, I'm going to use green for my line that joins both. And that's going to be the line AB. So I'll draw that in first. Oh, I forgot to do B actually, didn't I? 15 up and 85 down. There we go, there's B. Now I can join AB up. I'll do the same in elevation. And then I'll just pick orange for my AEB or ABE here. And calls it two different surfaces in this question. If you look at the question, it calls it ABE in the original description, and then in part D it calls it AEB, so whichever you want to call it. So I'm going to join B to E. and A to E. And there we go, there's our first plane in elevation, and draw it in plan. So, and now to partially complete the second plane, so A, B, C, D, so we can complete it in plan. So I'm actually going to use purple instead, or pink, because I picked another green. So I'm going to go B to D, or no, B to C, sorry, B to C, C to D, and D to A. Go B to C, and there we go. That's all we have in plan because we're missing point D. That's part A finished. And drawing our XY line in a bit heavier. XY, and there we go. There's part A complete. Now for part B. The question says, determine the height h. So determine this height. Determine the height h for point D and complete the elevation. So we need to find point D. To do that, we need to see that plane as an edge view. So point D is on plane A, B, C, D. So we need to find a true length line on that in plan, because as we know, any level line on a plane is parallel with our horizontal trace, which therefore means that if we look along that, we will see the plane as an edge view. So to find a level line, what we'll do is we'll come horizontal from point C, find where it hits the line AB. That will give us our point P. Basically, C to P will be a true length line in plan, and if we look along that, we will see the plane as an edge view. So to do that, I'm going to set up my T-square again. I'm going to draw a level line from point C over to hit the line AB. And where it hits the line AB, I'll drop that down and find it in plan, and that will give us our true length line. There. If we join C up to P and extend through, and then using our sliding set squares, we can bring point D up, point A up. We already have point C brought up, and point B. Draw our X1, Y1 line, and because we're projecting from plan, which means we take our heights from elevation, to make this a little bit easier, you can construct a datum here, but because we already have the heights in the question, so the heights for our points are already here, apart from D, we can just measure up as normal, which is what I'm going to do. So we don't have D. C is up 50, and this is C here. So if I measure up along that line 50 millimeters, that'll give me point C. Point B is up 15. Point A is up 55. And now if we join all three of them, they should correspond in a line, which they do. If we extend that through and then extend our D line up, where that hits, that tells us where point D is. So now we have the height h here. We take that height, step it off, we get our point D. So using our compass, I'll find where I left mine. Take our height D. So again, you could have took your heights for B and all using your compass. I just measured. It's just as easy when there's only a few points. Now we find point D. So again, I'm going to label these here: B, A, C, D. And now using our pink pen, we can join these back up to complete the elevation of the plane ABCD. And because this passes behind this plane here, it's going to be hidden detail. And there we go. Part A and part B complete. Next, we need to find the dihedral angle between these two planes, which means we need to find the common line, and I've already identified it using this green pen. Sorry, I need to move this a little bit. There we go. So we found our line of intersection. I'll label that there now. LOI. LOI. We need to find a point of view where we can see the angle between the two of them like that. And to do that, we need to look along the true length of the line of intersection. So to find the true length of the line of intersection, we must first look at that line of intersection perpendicularly to get the true length of it. So using either an adjustable set square or your sliding set squares, you need to create an x1, y1 parallel to your line of intersection. So I'm going to use sliding set squares. Keep this fairly close. There we go, x1, y1. And now if we project all our lines up, perpendicular to this, so extend that out a bit, and then bring up all our points. Technically we only need to bring 3 points from A, B, C, D, but 3 points defines the planar surface, but I'll bring up all 4 to prove that all 4 points will line up when we look along the true length line. And then last point, point A. And again, because we've projected from our plan, we take our heights from elevation. Now for this one, because there's more points, I'm going to reduce the amount of times I have to measure by moving up my x1, y1 and creating what's called a datum line here. So basically what we do now is we take our heights from this line instead of my x, y1. And what that means is point B is already on the ground, which gives us point B right here. And then I can use my compass to measure the rest of them. So for example, point C, take it from my datum line, find point C and measure it up. Point D, same thing. Point D, step it up. Again, skip past if you know what's coming up. Point A. And the last point, point E. The fact that we use that datum line actually reduces some amount of space we need on the page as well. There we go. Let's label the points. So point C, point B, point D, point E, and point A. And joining them all up like we've done before. So A goes to E, and E goes to B. And then we have AB as the common, or the true, or the line of intersection. and this will be the true length of the line of intersection in this instance. It's always good to label it TLLOI. And now finally we finish off the plane A, B, C, D, and try and visualize that if you look in this way, some of this is going to be in hidden detail. So for example, A joins to D. So going from D past this line will mean that we have hidden detail lines here. And then C goes to B, no hidden detail there. And C joins to D, no hidden detail there. Hopefully you can see that quadrilateral. One side, two side, three side, four sides. Same here, one side, two side, three side, four sides. Now that we have our true length of our line of intersection, if we look along that, we will see them two surfaces form in a V, giving us the dihedral angle, or the angle of inclination they have to each other. So to do that, we are going to project again along the true length line. Next, I'll bring this up a little bit. Make sure I have point C first. So I'll extend that one up. Bring up point C. D. And E. All very close in this instance. And now we need to also construct our x2, y2 line perpendicular to our line of intersection. Take your time, don't do what I did. Let the set square slide. You want to be accurate as possible. X2, y2. And now because we've projected from basically an auxiliary elevation, we take our distances from plan. So from this xy line back, or we can do similarly what we did before. We can move the xy line, create another datum line, which I will do through point D, which means up here point D will be right there on the ground line. Similarly, we're going to take the measurements now. Because point C is so close, I'm going to actually measure it physically. So it's 4 millimeters, 4.5 millimeters for me. So point C is there. Just because getting on the compass would have been a little bit difficult. Point B should be the same distance for point A. So we can double check that. By just stepping it up here. And it is. So AB will be 1 point. Point E which is here. Extend that line a little bit further to get point E. Right there. So E, C, what's after happening here? I take the right height for C. I take the right height for D. D should be out a little bit further. Don't know what I've done. That's right. D is definitely there. That's right. D should be on the far side of C. So maybe I've taken the distance for C wrong. And the distance for D wrong. I don't know what's going on here. Point D. How far down should D be? D should be down 40. And it is. It must be inaccurate somewhere because D should be out here so that we get a line like this. You'll see now in a second. So C should be like this. That there will be our dihedral angle. That is point AB. That's point E. And then point C should be here, and point D should be down here. But for some reason, my point D is here. I'm going to pause it and see if I can figure it out. Back in a sec. Okay, so found the issue. Due to just some my human error, this height here, the original height, it should have been about 2 millimeters higher, and then when I took the measurement I actually didn't take it accurately, which meant this was then a few millimeters short, which means when I take this height here, it is short here. It should be out a little bit more. Now I've done the whole thing correctly, it's just the point is a little bit off in accuracy, but it is working out still to give me a true dihedral angle, so the process is totally correct. So if you get a point like this, it's just down to maybe being off a little bit. I'll just show you using this rather than a traditional T-square. You'll see it does flex a little bit. I'm not saying it's an excuse, but it's just could be an issue, so that's just down to my accuracy. And then the last thing we have to do is to find the true shape of the surface ABE, or AEB as they call it in the question. So that's this triangular surface. Now to do that, we need to look at that triangular surface perpendicularly. So what we can do is we can rotate it down to be horizontal with this x2, y2, which will mean that this will then extend out further and we will get the true length, or the true shape of that surface. So what we'll do first is we will construct a horizontal line from point AB up here. We will then take our compass and rebate or rotate using rebatment of this plane. Rotate it down, and then parallel to this true length line, project it back and then perpendicular to this true length line, if we project out point E, that gives us our new point E, and just join it back to A and join it back to B, and then you can just label it TS of AEB, and that is that question complete from the 2020 mock paper that's on the State Exams Commission website. Thanks.